And welcome, students. We are now going to discuss multi-dimensional arrays in our new section here. And so for this lesson, we're just going to start off with talking about some multi-dimensional array basics. So getting started. Up to this point, when we've created an array, it has always had one index. However, Java will allow us to create arrays with multiple indices. These are what are called multi-dimensional arrays. So let's start with array declarations. It is sometimes useful to have an array with more than one index, and this is allowed in Java. Now the following will create an array of characters called page. The array page has two indices, the first index going from 0 to 29, and the second index from 0 to 99. So char array page equals new char 30 100. This is equivalent to the following two steps. You can do char page and then page equals new char 30 100. So it's just like what we've seen with our, when we've done variables, when we've done single dimensional arrays. Same process, except now instead of like one set of arrays, we have two sets. So let's talk about index variables. Now the index variables for the array have two indices. For example, page 00, page 1532, and page 2999 are three of the index variables for the array. Note that each index has to be enclosed in its own set of square brackets. All right, so it's very important that each of these have their own square brackets. Otherwise, it's going to throw an error. As was true of the one-dimensional arrays we've already seen, each index variable for a multi-dimensional array is a variable of the base type. In this case, the type char. An array must have any number, any number of indices, but perhaps the most common number is 2. All right, because most of the time when we're dealing with multi-dimensional arrays, you're usually not going to go beyond 2. All right, so you'll either have just a normal array, which is of course an array index, just what we've been doing, just 1, or you'll have 2. Very rarely will you go to something higher. Now, a two-dimensional array can be visualized as a two-dimensional display with the first index giving the row and the second index giving the column. So it's a good way to kind of think about how an array is set up visually. For those of you that might remember matrices from Algebra 2 or Algebra 1 even, you can kind of think of it as a single-dimensional array being a 1 by whatever matrix. It has one row with multiple columns, whereas a two-dimensional array is row by column. So it's obviously going to have two dimensions there. So not just length, but length and width, or in this case, column and row. So, for example, the array index variables of the two-dimensional array A, declared and created as char A equals new char 512, can be visualized as follows. So you have A of 00, A of 01, A of 02, all the way up to A of 011, and then conversely up the next row, A of 10, A of 11, A of 12, all the way up to A of 111, and so on and so forth, all the way down until A of 40, A of 41, A of 42, yada, yada, yada. So it's really just, kind of a big coordinate grid. You might use the array A now to store all the characters on a very small page of text that has 5 lines numbered 0 through 4 and 12 characters on each line numbered 0 through 11. All right, so with that in mind, let's talk about how you declare and create a multi-dimensional array. So you can declare a multi-dimensional array variable and create a multi-dimensional array object in basically the same way that you create and name a one-dimensional array. You simply use as many square brackets as there are indices. So the syntax is the base type array dot 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 all the way up to the last array bracket. Variable name is new base type length all the way up to length. So let's just look at a couple examples here. So here I have a char double A equals new char 512. Char double array page equals new char 30 100. Those are two that we've already seen. But here's an example with a double array, or I'll just say double array equals new double 110. Int array figure equals new int 10 20 30. You'll notice that that is not a two-dimensional array, but a three-dimensional array. And then you have person array entry new person 10 10. Person, of course, being a class. All right, now. You did see just here a second ago a three-dimensional array. So it's important to note that when we start talking about multi-dimensional arrays, the way to think about them is that they're really more like an array of arrays. So in Java, a two-dimensional array such as A is actually an array of arrays. Because remember, array is like a row. So really, then when you create an second one, you make that column dimension, you're saying, hey, I'm going to make a stack of those arrays, and I'm going to store inside of a second array. So the array A on the previous slide is actually a one-dimensional array of size 5, whose base type is a one-dimensional array of characters size 12. All right, and this is diagrammed on the next slide, so we can kind of see this a little bit better. As shown in that display, the array variable contains a reference to a one-dimensional array of length 5 with a base type of char. That is, the base type of A is the type for the entire one-dimensional array of characters. So you can't change your base type. You know, it's like, hey, I'm going to start the first half as int, and then I'm going to make it a double. No, it has to be the same. Each index variable, A1, or A0, A1, and so forth, contains a reference to a one-dimensional array of characters. So let's take a look here at the diagram, which illustrates how a multi-dimensional array works. So here I have a char array, A equals new char 512. All right, and then the code that fills the array is not shown in this diagram, but just to kind of give you a visualization, here is A of 0, A of 1, A of 2, A of 3, and A of 4. So each of these, you know, are a single array. Then that each array is made out of 11, A 0 through 11, so it's 12 characters here in the array, so there's 12 indices. So that's how we get when we start talking about an array of arrays. So we have here an array, and here we have another array, and another array, and another array, and another array, and each of these 5 arrays are then stored here in these 5 rows. So when you see 512, these, you can think of the 12 as the first array, and then 5 would be the next array. If I had a 3-dimensional, it would then be the following value. So whatever is the smallest one is always last. So, and then we can see right here with the code, it says we will see that these can't should be replaced with expression involving length instance variable, which I'll talk about here coming up. So in row column, 4 row equals 0, row is less than 5, row plus plus, 4 column equals 0, column is less than 12, column plus plus, system out print line, A of row column, system out print line, just use the space. And this one, oops, in this case, will produce the following output, because you notice there's characters stored in here. Once upon a time, there were 3 little programmers, because those are stored, what's stored in the array itself. All right, so not just limited to 2 dimensions. As we've already talked about, a 3-dimensional array is an array of arrays. So it could get kind of confusing. All right, and obviously it can get, you know, if we had a 4th dimension, it would be an array, an array, an array of arrays. You can kind of get the concept. It gets pretty tongue twistery. So normally the fact that a 2-dimensional array is an array of arrays need not concern you. Right? And you can actually, you should just act as the array is actually an array of 2 indices rather than an array of arrays, which is much harder to keep track of. You know, because you start saying it's an array of arrays, and you're going to be like, what? But if you say, hey, it has 2 indexes, that's a little bit easier to remember, and also it's easier to remember is, you know, if you have an array index 1, it's just a length. If you have, excuse me, not an index, but if you have 1 index, it's a length, and if you have 2 indexes or 2 indices, or 2 values there for your array, so you have a 2-dimensional array, it's length and width. So there are, however, some situations where a 2-dimensional array will look very much like an array of arrays. For example, you'll see that when we use the instance variable length, you must think of a 2-dimensional array as an array of arrays. And I highly recommend that you use the length instance variable simply because then you don't have to worry technically as much about the exact value of how many characters or indexes are inside of that array. So let's use that length instance variable. So suppose you want to fill all the elements in the following 2-dimensional array with the character z. So here I have char array page equals new char 3100. So you can use a nested loop such as following int row column, 4 row equals 0, row is less than page.length, row plus plus, 4 column equals 0, column is less than page. Notice that right here it says bracket row dot length, column plus plus, page row column is equal to z, and that's it. All right, let's now look at analyzing that loop so we actually have a little bit more understanding of how that loop works. So let's analyze this nested loop. The array page is actually a 1-dimensional array of length 30, And each of the 30 index variables, page 0 through page 29, is a one-dimensional array with a base type char and a length of 100. That is why the first for loop is terminated using page.length. For a two-dimensional array such as page, the value of length is the number of first indices, or equivalently, the number of rows, in this case, 30. Now let's consider the inside for loop. The 0th row in the two-dimensional array page is the one-dimensional array page 0, and it has page 0.length entries. More generally, page row is a one-dimensional array of chars, and it has page row.length entries. This is why the inner loop is terminated using page row.length. Now, if this is a little confusing, you can, of course, switch back to using hard-coded values of whatever the number is. So if you want to use like 5 and 12 or whatever it's supposed to be, you can do that. Or if it's like a variable that captures the user input to determine the length of it, that's fine as well. Now, of course, in this case, page 0.length, page 1.length, and so forth, all the way up through page 29.length are all equal and are all equal to 100. Now, later on in our next section, actually, we will discuss what is known as a ragged array. And you can see that in this case, when we get to ragged arrays, they don't all actually have to be equal. Right? But that's going to kind of wrap us up for today, folks. So hopefully it kind of gives you an overview of how multidimensional arrays work. And I will see you next time.